So may I then request Shri Tandon to start his presentation.
Gentlemen, I must convey my most thanks to the organizers, especially Dr. Sen Gupta and Mr. S.K. Gupta, who have been in touch with me, a long-term association. With your permission, Chairman, I'll just commence my presentation. See, the focus on this environmental issue arose from the strategies which I am going to put on the EP Act 1986 April. Gentlemen, I had been associated both with Indian Oil, all the refineries almost, for more than 3 decades, and also ONGC, MRPL for 5 years or so. And I had the privilege to visit all the refineries of India, including ONGC, many or whatever petty refineries, and a dozen of refineries overseas in US, UK, Japan, Thailand, Malaysia. I had been in Petronas for more than 3 years as head of technical for their petrochemical plants. So by virtue of that experience and my association continued with the environment also, where I was responsible in IOC, I have assembled some of the strategies how to comply with. I heard a voice from some refineries I visited. There are some of the things that are very difficult to comply with, the new enactments. But to my knowledge and to my experience, I think it is all possible. And it is one of the wonderful piece of enactment, EP 1986. It includes everything, right? The water, the air, the atmospheric emissions, and what control standards and monitoring should be there. So, keeping in view of these standards, I have prepared my presentation, which I will present to you. So I am just, not for the education's sake, just putting this definition of pollution prevention is a multimedia concept. The whole idea, as Mr. M.B. Lal was narrating, in the refineries sector all world over, it has a very long history, and it is a more organized sector, and it has come a long way, for sustainable development of technologies, practices. So API have put this, the definition. I particularly want to focus on that. It should be more based on the, prevention and reduction at the source of pollutants, as well as the recycling. And this, to my knowledge, is not by and large being practiced as worldwide many national refiners are doing. So I think otherwise we have all the system in place, and we want to comply, and we comply, and the standards sometimes definitely difficulties people are experiencing. So those are critical issues I will highlight. It's a long presentation. We are So these are issues, aspects, and total and consolidation, water resource, treatment of wastewater, recycling treated. This is the water conservation is the major thrust these days, because water is a very scarce resource. Control of toxic atmospheric emissions, fugitive emissions, soil sludge, control of CO2 emissions, disposal of spent catalyst. Now, conservation of water, which most of the refineries, they have good state-of-art cooling towers and all that, heat integration. I will not, but only one aspect which Indian refineries are not doing, we are using a lot of water for housekeeping. I think there need to be a direction. You should go for the vacuum sucking of all the solids. I have seen the centralized vacuum system, they work wonderfully well, and because the solid which go along with the water and oil spilled, and that creates a lot of sludge. So if we resort to vacuum cleaning and housekeeping, it can give long way to to reduce the pollutant loads. Rainwater harvesting, I think this also is a good option and all that. And the cooling tower, that will come back to the first, it is mostly refineries should or maybe doing is a very high cycle of concentration. Your makeup water is reduced considerably. So that is one of the good way, and air cooling is maximum being practiced. Modern refinery, maybe old refinery where water is plenty. And you look at the case of Chennai Petroleum, who has to recover water only from the sewage. So cost of water, they can have, you can have a sympathy with them, is a lot. These are the standard, the amendment. The oil is 5 ppm for the refineries now, and of course the BOD remains 15. Other is standard solids 20. Phenol has been reduced 0.35, and then sulfites also is 0.5. Now, most of the refineries may be meeting because they have a good, well-designed effluent treatment plant. But still, as we were thinking, Lal also was emphasizing, we should think ahead of legislation, self-control, so that gives a good image to the refinery. So these are the just standard. Now this is the typical refinery wastewater, which we have the sump, PPI separator, PPI, CPI, DAF, hydrogen flux. It is one of the modern refinery which I picked up, the Bangalore refinery. So it's a tertiary treatment, which is the filters. They do the job of current and all can be used for as a makeup in the cooling tower if your TDS control and your oil should be less than 1 to 2 ppm, and there are refineries who are having less than 2 ppm of oil. Bangalore is one which is always less than 3-4 ppm only. This is what I was ETP which I described. So what I just highlight some of the point. Sorry. Okay. Some breakdown. So what happened? No.
Say no to drugs.
कंप्यूटर सीखने के लिए कह रहा है।
So some of the strategies which for some may be there, but what I would like to highlight, the salter operation, the crude desalting, is a these days refineries have to process multiple crudes in sequence and all that. Sometime the salter your brine, it contains varying quantity of oil and all that, and that poses a big problem in the effluent treatment plant. And this is a treatment of brine before discharge to OW system. I think very few refineries, and overseas it is one of the very important point to tackle, the oil going into the OWS must be recovered before cooled brine is discharged to the ATP.
What is OWS?
Recovery of oil through
OWS.
separator, crude oil, storage tank, drains and all the loading
OWS.
facilities. They are not directly routed, the drainage, it is through some separators, so that you can recover the oil in plant rather
Oil water
than
separation.
recovering at ATP where a lot of
Oil water separate.
it will be vaporized and you will be losing a lot. The treatment of spent caustic to reduce phenols, organics and all that. This also is one of the key issues which I think refineries are not here in India, not having the in-plant recovery system. So tertiary treatment to minimize this kind of solid recycling to cooling power. Now this some kind of RO, partial RO treatment is required, and it may be worthwhile to recover even your boiler feed water. Gentlemen, I think in 2000 I visited one Mitsubishi refinery in Japan, the Hapu refinery. You believe me, and the effluent treatment plant, it was something surprise to me. The influent oil was less than 100 ppm. It's a dream because they had very small effluent treatment plant, just 100 into 70 meters. It was enclosed. So we have a lot of space occupied and all that, because unless until we have control on the plant itself to recover oil, is very difficult. TTP operation becomes quite messy. Recovery of oil, handling slop oil, draining, then recovering slop and processing. So this the biological treatment takes care of normally residual phenolic and ammonia removal to nitrification route. So dual media, I need not focus this already. Stripped sour water containing phenols are best recovered substantially through the use of wash water and crude salt. Because a lot of overhead water from the cooker, cooking the technology, which is most of the refineries have now adopted, and FCC, they contain phenols. And these phenols, if you, wash water you use desalter. So this phase transfer takes place and you can reduce the phenol rather than taking to the ATP. These are other few things for better desalter operation, low pressure water to avoid turbulence, optimum interface level control, sensors like displacers, capacity. This is all better instrumentation because the interface level control is very important. And whatever we think that the sludge which periodically is drained from the desalter, this should be, it can be processed in the cooker rather than taking to any sludge pit and all this. So good desalter invariably, at lot of quantity of oil, to frequent changes of crude unit operation beyond design capacity, processing a heavier crude. Very few refineries, they might have debottleneck desalters unless until very, but 10, 15, 20% debottlenecking, because sometimes desalter poses a constraint. You cannot achieve whatever the brine quality which you can get slightly lower. So surfactants are also there. So this brine treatment is very much required. This is the scheme which I just highlight. This is it's not a very costly proposition. You need to have a separate vessel, and if you can separate the oil, and if there is a sludge in the little bit in the brine, you can add little bit naphtha and some polymer you can add if it is required. Now this gets separated and you can treat it water to the sewer will be much less. Actually, this is one of the practice API also is recommending in their guidelines. Spent caustic is a lot of use is there from the gas, LPG, all cooker streams and all that. This is can be used in recycle somewhere if you have to add in the crude unit also. But the best way is to treat implant because it contains a lot of phenols and all that. Even you can have oxidation technology also. But what are my suggested scheme? It is this is something. This is also from API. Here, these phenols that get separated, in a column, and you can recover. Actually, it is at the pH need to be reduced to 3 level, and then the phenols get totally separated as is phase on the top, and you can get the water, sewage water, lower than very high recovery of phenolic and other aromatic compound all together can be recovered, and this can be blended to the some products also in small quantity, and gas also can be recovered as a fuel gas. Now these are the emissions. Now we come to atmospheric emission control. So now the normal furnaces, boiler and refinery furnaces, they have reduced the limit for the gas, which will be only 50 ppm gas firing, liquid firing. For the new refineries, 850, and oxides of nitrogen, carbon monoxide, we all could be with a better sulfur content in the fuel can be achieved. But particulate matter 10 and 5, I don't think it's easy to achieve this standard. So my suggestion will be natural gas poses no problem. But combination of fuel gas and natural gas required well designed filter to remove water and drain solids. Some of my refinery old colleagues are sitting over here. I just want to share. I had worked in Malaysia petrochemical plant where it was MTB plant, propylene production also, and propane to propane dehydrogenation. Very high temperature process, 650 degrees centigrade. We were using natural gas because Petronas produces a lot of natural gas. Believe me, the natural gas we have to pass through a filter, well-designed filter. It takes out any amount of condensate, it takes out any solid and drain material. It can take out water and all that. You believe me, the burners have never been cleaned for 2 years. So we are having only knockout vessels for the gas in the refinery. So it's not a very heavy investment, And if you have to meet that 5 ppm standard for particulate and all that, you need to put filters in place. Liquid fuel with most of the refinery now 0.5% sulfur content, SO2 emission limit is met. SPM control to 50 ppm looks difficult unless until 50 ppm with the fuel oil. It all depends on because we use a lot of residual streams from refinery which are not converted into saleable products, and those are the fuel oil. And unless until you have a good filters in place, you can't achieve. Gentlemen, people may think that SPM is not a very critical item in the flue gas and all that. I think differently. If your SPM is more, you have an NOx, you have a SO2, all these combined together, it creates it's a different kind of phenomena And that is very, I think, the health hazard potential that inhaling along with the SPM and all that. Why we have gone to 2.5 and all that? Reason is to control the respiratory and all that kind of problem. So if SPM is not met, the people should not think it is not critical and all that. That's what I just wanted to emphasize. And in US refineries, if they are not meeting, they are not 95%, 98% control, they are fined heavily. There is no structure to find the refineries and all that. It's a different matter, but we are more organized sector, we should stay ahead of legislation. Now coming to the FCC, this is a very important unit which is a profit-making unit for the refinery, product balance. Here also they have put the new refinery FCC, which should be very high, low, SO2 500 ppm, and hydroprocess otherwise also 500. Most of the FCC are having now hydroprocess feed, but this hydroprocess feed is combined also with some amount of untreated, unhydrated feed from low sulfur processing, because otherwise you don't get better operation of the FCC. So this control is maybe possible to get it, but few suggestions are there. In case of higher than 500 ppm sulfur in the feed, desox liter also can be added. This have efficiency of 20% removal, depending upon the feedstock. It leads a trial and all that. Wet gas scrubbing with caustic flue gas is another option, but some refineries have put it. But overseas, come to know it's not a practice because it's a very complex operation. Very high flow is maintained and it leads into the generation of sludge which has to be disposed. It's a very, we have to dispose and landfilling. There is no that kind of guideline and all that. Maybe overseas refinery can dump into the sea. That's a different matter. So compliance with standard of 50 milligram per millimeter cube. This additional measures for the FCC is required. Many refineries might have done it, but some refineries I feel they are not done it. Tertiary cyclone separator for flue gas. This is needed to catch, the less than 5 ppm for less than 5 micron also. It is all possible. Efficient filtration of atmospheric air. So this is a concept which refineries are not doing. They are sucking air for main air blower for the FCC operation. That itself is containing a lot of suspended material, and you don't have an efficient filtration system. But now this concept, I think it is getting into when they are going for modernization of the FCC. This is very much required. Capturing fine catalyst particle through precision plus vanadium, this limit can be achieved. So FCC also needs attention if you are not able to meet the SPM, because catalyst attrition takes place during the cracking operation, and that catalyst less than 5 ppm, 5 micron, a lot of particular emission is there. Could be more than 3-4%, unless until you capture outside the multiple cyclones. It's not possible to get very low micron from the exhaust. Now, as for you, I do not spend much time.
You have to go a little fast. Another 5 minutes you should try to finish.
Because there is a add-on stage, for residual SO2 to be again either through converting into H2S and taking it back to the unit, and you can maintain your emissions, whatever has been legislated. But if you do SRU operation below 60%, your emission level will increase. So that is the catch point. The fugitive emission, there is a, I think, supposed to be a separate, I will not spend much time, but accept some of the key issues which I can. This is a floating roof tax. Most of it is to avoid fugitive emission. They have come up with a good, I think, very stringent standard on secondary seal and all that. Now this, lot many tanks originally they are not having secondary seal, refineries have to convert, and they will find difficulty in this to meet ports. But a very low gap with the storage tanks, floating roof tank. So these are the limit which is for the from the equipment and all that, and international as compared to international standard, they are very high. Now the regime is 500 ppm by API. So this is a, I mean this is well under the standard on the monitoring, quarterly, annually, and all that. Just to double seal mechanical pumps, most of the services where hot to lighter components are there which should be used, and only the steam injection, which due to energy conservation refineries sometimes they don't want to put steam to the flare. I think this is, but flare recovery is the best option. I think this is what we should practice. This is another drainage should be, it should be through the automatic draining system, it should not be left to the manual control, because you can let up more oil, And some of these products are all there through the pollution, which is remove water in plant only. This from OWS, there are a lot of, if the influent is open, there's a lot of problem on fugitive emissions, because it's a first catch point for receiving raw effluent. So, though you may have all closed blowdown, closed system and all that, but fugitive emissions are there. If many refineries are trying to put recover oil in the influent sump itself, this is something which it needs to be avoided, and I have a few points on that. The recovery of oil from the brine to reduce the load on the ETP, cooling of brine, collection of oil, which are just automatic draining, provision of floating roof tanks for volatile products, ETF. Use of cover with vapor space, they are put it in that you should vapor recovery system on the oil separator. This may not be possible because it will be handling the explosive mixture. So what I have put in the suggestion, and there is a spray system. The treated effluent like a parabolic, you can cover, and all the fugitive emission again will be condensed and it will be in the API system. So instead of that, it is not possible to, it will be dangerous, I think, to have compression from that. And covering and all that, food and all that, it cannot be very leak proof and all that. So air will be there with the hydrocarbon, and the compression, it will be a problem. But the sludge, best option is to process in the coker, recycle. Just accept, I think, Reliance refinery, nobody is doing, to my knowledge. Maybe the schemes are in place, it needs to be done. And it gets, all the oil gets recovered, and coke, it is being used as a fuel grade coke. It doesn't increase much, because overall the limit which is far higher. And as compared to the this coke, and as compared to the coal, which is having very high ash content, and it is blended, and it can be used by the cement manufacturer. Your Indian coal is up to 40% of the ash, and this serves a good. Reliance is able to sell all the pet coke to it is a big demand. So these are the recycle scheme which I was showing, either with feed or with the along with the cooling of the coke chamber. This is it is being practiced. I take another just 2 minutes only. This future emission control and monitoring, that has got a lot of dividends. Reading an article, US refinery has shown more than 50% reduction. This is a phenomena which, this is a control which refineries have to vigorously pursue. So, less than 500 ppm also can be achieved. I was looking at the data on refinery, more than 10,000, 15,000. Now those critical surveys, we should replace the walls, and have almost zero, very tight. And that wall can be used somewhere else in the non-critical, See, there is a economic benefit in fugitive emission reduction. It's not for the sake of environment emission legislation we have to do it. If you pursue it, it is all possible to save a lot and better atmosphere. Now these days, US refinery is using the laser technology to detect future emission, video imaging. Now I'll not accept that the CO2 emissions definitely must have gone up from the refineries, because pressure is more on the now new fuels. It requires more of hydro processing and all that, and hydrogen, production of hydrogen causes CO2 emissions as compared to any other refinery process. This is the CO2 emission factor with a different fuel and all that. This must be, may not be highly accurate, this is just typical. I have an opinion we should avoid bioremediation of oily sludge, because it's not that metals, apart from the metal, you are emitting CO2, you are converting oil into CO2. So what is the use of that? So there are technologies available which can reduce the oil to less than 5%. And they are very commercially proven technology. You can have a 3-phase centrifuge which separates oil, water, as well as that the sediment, and you get almost dry sediment out of it. I'm just giving you a typical scheme of that. This is, from the tank, this is shown for the tank desludging and all that. There are robotic systems, there are outside control to suck out the sludge from the low pump, and there is it is pushed into the high solid processing unit, which is fitted with a lot of mixers and all that. So the sludge is to be homogenized before it is taken to the centrifuge, decanter centrifuge, which is a 3-phase and all that. Solids are separate, and the water which is recovered, and it's less than 10 ppm, it is not possible to put it to OW system. So this kind of technology is being practiced. There are mobile units also in outside our country, and best way to recover oil, because oil, whatever it is, whether $70 or $100, it is very precious commodity. So the sludge, tank bottom sludge, it contains 80% of oil. To my knowledge, if I have got 80 to 85% of oil. So this is what it requires concentration. The catalyst, just 1 minute more. The catalyst, platinum catalyst, base catalysts are recovery, they get the platinum recovered, we send to the same supplier and all that. But hydrotreating catalyst, now there is no guidelines and all that. I am just putting, as for the EPA, this is been declared spent catalyst and hazardous waste. It contains molybdenum, nickel, cobalt, because the hydrotreating catalysts are quite, almost every refinery is using, and after 2 or 3 regeneration, if you do it, they get deactivated. So this need to be disposed. Best option is to sell this with the permission of the State Pollution Control Board and MOE. They are organizations who are recovering metals and all that. So this is the best way to dispose of spent catalyst. Now FCC catalyst, it is, there are 70, more than 70 FCC in US. And all the FCC spent catalysts goes to the cement manufacturer. But I think this need also to be coordinated with because this it is containing whatever ingredients, metals and all that. They are binders for the cement. Nickel, ferrous, vanadium, chromium. They are all in low concentration. So this is a recycling is very much desired. Thank you, gentlemen.